Hi, my name is Abby Urbanavage, and I am an undergraduate researcher for the University of Delaware's Summer Envision program. My project title is Primer Design and PCR Optimization for High Multiplex Long-Range Amplification. I have been working with strands of DNA that contain 5,000 base pairs and designing primers to amplify regions of this long-stranded DNA. We are working primarily with growth and longevity genes and are looking through regions that have been previously associated with an avian disease called wooden breast disease. Wooden breast disease is found in the fast-growing meat-type chicken, or broilers. It affects the pectoral muscles, significantly degrading the quality of the breast, leaving the texture hardened or rubbery. The muscles tend to be tight and causes discomfort, pain, and a limited range of motion. I have been tasked with using PCR procedures to identify the gene mutations that are associated with this disease. The designing of primers was our first step, and with help from NCBI Technology and my professor, I was able to design over 100 primer pairs in about 2 weeks. Primers are single-stranded sequences that are designed to bind to specific DNA sequences, which allows DNA polymerase to amplify our desired region. Our experiment required so many primer pairs because of the disease's polygenic tendencies, meaning it is expressed by multiple genes. Next, I was tasked with preparing all of our primer pairs into DNA samples and running them through our thermocycler, or PCR machine. Thermocycler cycles the samples through different temperature levels, which breaks up the DNA, allows the primers to bind, and gives DNA polymerase a starting point to amplify the target sequences. Once put through the thermocycler, we use electrophoresis to compare the PCR product to a ladder that offers us a visual result. The process of electrophoresis uses an electrical current sent through a gel to move PCR product from a negative charge to a positive charge. We use a ladder which will expand and give a scale for where the successful product should end up in the gel. The result we are looking for will be displayed as a single solid line. The alternative will be expressed as multiple lines under a well. We call this nonspecific product, and it means our primer has amplified multiple sequences, which is not likely our target sequence. We can rule these genes unhelpful in our experiment. It took a few trials for us to achieve the results we wanted in the most efficient fashion. Unlike my previous lab experiences, I am able to alter our procedure based on whether the results are successful or not. I have learned to look at the results and decide if there was a better course of action. Aside from my primary lab work, I have also been tasked with assisting a connecting project that also focuses on chicken gene identification. We have just recently received our first hatch of eggs and set them up in our facility's incubators. Soon, we will start routinely performing necropsies, collecting tissues from the chicks at different stages in their development. This project focuses more on myogenesis, which is the development of muscle. We are trying to identify alleles of slow growth versus fast growth in a select array of crossbred chickens. In this experiment, we are using Leghorn and Fiume breeds of chicken. My main task is to assist in the care and collection of the chickens. We have already performed a few necropsies on our first hatch and have collected samples from the embryo's head, heart, liver, and pectoral muscles. Once our chickens hatch, I will be monitoring them in their isolated habitats, and we will continue to do our routine necropsies. I have also been helping with our egg candling procedures, which is important for us to weed out the unfertilized eggs from the fertilized ones. We can find the difference by observing how the light goes through the egg and seeing if we can detect vessels and a fertilized embryo. Even though research of this kind is not my field of interest, I can tell that the work I am doing will be invaluable, and I have learned so much during my time in this program. I will forever be grateful for the opportunity I was given. Thank you for watching.